You're listening to DTFHN for February 28th, 2026. I'm your load-bearing host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who build the exits also design the locks. Today's a day where every door you open has fine print on the other side. Let's read it together. There's a detail on this page that most people will scroll right past. Buried in the deletion flow, after you've navigated to settings, after you've clicked through to account, after you've found the delete option, you hit this line. You may only delete your account if you have logged in within the last 10 minutes. 10 minutes. They built a timer into the exit door. Now, there are reasonable security explanations for this. Session freshness, identity verification, protecting against unauthorized deletions. Fine, but run this forward. You are a user who's decided to leave. You've made your choice. You log in, you navigate the settings, you find the option, and the system tells you, not yet. Log in again. Prove you mean it. Type your email. Type the word delete in capital letters. Then, and only then, do you unlock the button. This is not a technical limitation. This is a retention funnel disguised as a security measure. Every friction point is a moment where someone might change their mind. Close the tab, forget about it for another month, and another month of an active account is another month on the user count that gets reported to investors. The comments on this article tell the real story. People reporting that login codes mysteriously stop working when they try to delete. Error messages about too many failed attempts. And this gem from the fine print: new accounts are limited to 3 per phone number. Delete your account and you've burned one of your 3 slots permanently. Your departure has a cost that persists after you've left. Compare this to what deletion looks like when a system respects user agency, a single confirmation, a clear timeline, no psychological obstacle course. The architecture of an exit tells you everything about how a company views the relationship. Are you a user or are you a metric? And then there's the data retention language. Your data gets deleted within 30 days. Except we may retain a limited set of data for longer where required or permitted by law. That word permitted is doing enormous work in that sentence. Required by law is a constraint. Permitted by law is a permission slip. The gap between those two words is where your data lives after you think you've left. The people in the comments talking about boycotts and switching providers are responding to something real, even if they can't always articulate it precisely. When the exit is harder than the entrance, when deletion requires more authentication than sign-up, when your phone number is permanently scarred by your decision to leave. The architecture is telling you something about who this system was built to serve, and it wasn't you. Different kind of trust problem now. Story 2. Don't trust AI agents. NanoClaw published their security model this week, and the core argument is simple. Don't trust AI agents. Not trust, but verify. Not trust with guardrails. Don't trust them. Treat them as potentially malicious actors and architect accordingly. Now, let me play the other side for a moment. OpenClaw runs on your machine. You installed it. You configured it. You gave it access. Isn't distrust a strange posture toward software you deliberately chose? You don't run your text editor in a container. You don't sandbox your terminal. And that's exactly where the argument collapses, because your text editor doesn't improvise. Your terminal doesn't decide what to do next based on a probability distribution over tokens. The moment software has agency, the threat model changes categorically. You're not worried about bugs. You're worried about creativity. NanoClaw's answer is container isolation. Each agent gets its own sandbox, its own file system, its own session history. Your personal assistant can't see your work agent's data. The container boundary is enforced by the operating system, not by the application asking nicely. This matters because application-level security, allow lists, confirmation prompts, safe command lists, all assume the agent is cooperating with the security model. That's the definition of trusting the thing you said you wouldn't trust. The comments are split in a revealing way. Some people point out that containers aren't perfect security boundaries either, which is true. Docker escapes exist, but the response isn't containers are pointless. It's containers plus least privilege plus ephemeral destruction is a fundamentally different posture than running directly on the host with an opt-in sandbox most people never enable. One commenter nails the deeper problem. The trust issue isn't just vertical. You're trusting your agent. It's horizontal. Agents trusting each other. Once you have multi-agent pipelines, one compromised upstream output poisons everything downstream. Isolation between agents isn't paranoia. It's basic hygiene. The uncomfortable comedy here is that we're building systems sophisticated enough to require adversarial security models, and then we're surprised when they need adversarial security models. The architecture is the confession. Every container boundary is an admission that we built something we can't fully predict. NanoClaw is 1,200 lines of code. OpenClaw is approaching 500,000. That ratio tells you something about where the complexity should live. The security model that works is the one small enough to actually read. Moving on. In 1863, a group of telegraph operators at the War Department realized something unsettling. They had built the most powerful communication network on Earth, and now the government wanted to use it to read every citizen's mail. The operators didn't quit. They didn't leak. They wrote a letter. It didn't work, obviously. But the letter survived, and it became one of the earliest records of technologists drawing a line between capability and consent. 160 years later, the pattern repeats. Current and former employees at Google and OpenAI have published an open letter at notdivided.org, asking their companies to re-EVREVGAAZ, the Department of War's demands for permission to use AI models for domestic mass surveillance. The verification system alone tells you how serious this is. Signers authenticate through work Google accounts, or upload badges, or get vouched for by colleagues. Anonymous signatures appear as verified current or former employee, with personal data auto-deleted within 24 hours. They built an identity verification pipeline specifically so people could speak without being identified. That's not a petition. That's operational security for dissent inside your own employer. The engineering analogy that keeps surfacing for me is load-bearing walls. In any complex structure, certain walls aren't decorative. Remove them and the building comes down. The norm against turning surveillance tools inward is a load-bearing wall in democratic society. The letter's organizers understand this structurally. They deliberately kept the ask narrow. One demand. We want the specific capability. They're not relitigating military contracts or AI ethics broadly. They identified the single point of failure and put pressure exactly there. One commenter raised something worth sitting with. If Anthropic gets punished for refusing similar demands, that becomes a signal to every technology company on Earth. Compliance is the only viable business strategy. That's how norms collapse. Not through dramatic confrontation, but through the quiet arithmetic of what's survivable. The letter isn't affiliated with any party or advocacy group. The organizers describe themselves as a few citizens concerned about misuse, and the signatures are accumulating from people who build these systems, who understand exactly what domestic deployment means at a technical level. When the people who write the inference code tell you a particular use case crosses a line, the minimum responsible action is to listen. The tools exist. The question, as always, is who holds them and what they're pointed at. Now, the people building the tools we actually want to use story 4, Unsloth Dynamic 2.0 GGUFs. In 1996, the JPEG committee made a decision that shaped 20 years of image compression. They published their quantization tables, the specific matrices that decide which visual information to throw away, as suggestions, not requirements. Every camera manufacturer, every browser, every image editor could tune those tables to their own hardware and use case. The result was an ecosystem where quality kept improving without breaking compatibility. The tables were the leverage point, and making them open meant everyone could pull. Unsloth just did something analogous for large language models, and the implications deserve more attention than they're getting. Their dynamic own quantization system treats every layer of a neural network as a unique compression problem, not one quantization scheme applied uniformly. A custom-tailored approach where the bit allocation for layer 14 of Gemma 3 differs from layer 14 of Llama 4, because the information density differs. Run that principle forward. This means a 3 billion parameter model on your laptop isn't just smaller than the original. It's been surgically compressed by someone who measured exactly which neurons carry the most signal. The benchmarking methodology is where this gets genuinely interesting. Most quantization papers report perplexity. Average surprise across tokens. Unsloth argues this is misleading, citing research showing that quantization can flip answers from wrong to right and right to wrong simultaneously, with the errors canceling out in aggregate metrics. Their preferred measure is KL divergence. How much the quantized model's probability distribution diverges from the original. It's the difference between asking, does this model perform similarly on average, and does this model make the same decisions? That distinction matters enormously when you're running a quantized model for medical triage or legal analysis. And here's what the benchmarks actually show. Unsloth's GGUFs outperform competing quantizations while being 8 gigabytes smaller. They're publishing these quants for free. The calibration dataset. 1.5 million tokens of hand-curated data. Dem beer duer die right到龙来家贴上贵的用不度有相当lang的度头来动词中都是跟台是跟团都怎么那么是我不的写习了上面的熬到no头那么就的 users 他们所加的超载他们能并还找得到的种种是都看出的可还是后点的都碟子这能第三监管的The tools exist. The calibration data is available. The quantization tables are open. This is how the ladder reaches the ground. 5 stories in, and we're still finding things that make you lean forward. This one's a visual trick worth seeing. The strongest case against SplatHash is obvious. Why would anyone want 16 bytes? ThumbHash already gives you a reasonable preview in 25 to 37 bytes. The difference is negligible in any real payload. You're saving maybe 20 bytes per image, and the visual quality of those 6 Gaussian blobs looks frankly like someone sneezed watercolors at a canvas. The comments confirm this. Multiple people tested it, and found ThumbHash produces more natural results. One person pointed out the splats create false contrast, implying sharp features that don't exist in the source image. These are legitimate criticisms. Now let's look at what those criticisms miss. 16 bytes is not just small, it's 128 bits. That's a single integer. You can store an image preview in a database column designed for UUIDs. You can pass it as a query parameter. You can embed it in a protocol buffer field that was allocated for a timestamp. The constraint isn't about saving bandwidth. It's about fitting into places where images were never supposed to go. The decode benchmark matters more than the encode. SplatHash decodes in 67 microseconds. ThumbHash takes 500. BlurHash takes 6.5 milliseconds. Decode runs on every page load for every user. Encode runs once. The author optimized for the operation that scales, not the operation that feels important. That's an engineering decision worth examining. The architecture is worth examining too. 6 Gaussian blobs placed by matching pursuit, colors optimized by ridge regression, all computed in OCLAP perceptual color space packed into exactly 128 bits. Every implementation, Go, TypeScript, Python, produces bit identical output, not approximately identical, not close enough, identical. The spec is published. The algorithm document ships with the repo. Anyone can write a conformant encoder in any language and know it will produce the same hash as every other conformant encoder. That property doesn't exist in ThumbHash or BlurHash. Their outputs vary across implementations, which means if you're building a system where the hash is a key, where you need to look up or deduplicate by preview, those tools can't do it. SplatHash can, because the output is deterministic by specification, not by accident. Is it the right choice for every image preview? No, the visual quality trade-off is real. But the interesting question isn't whether 6 blobs look as good as a DCT decomposition. It's whether a fixed-width, deterministic, integer-size image representation unlocks uses that variable-length fuzzy previews simply cannot. The spec is open. The implementations ship in 3 languages. If the answer is yes from your system, the tool is there. We talked about tools that do exactly what they promise. Story 6 is about the oldest promise in computing, pause, and why it never delivered. One commenter puts it plainly. Developers are unwanted overhead until the customer money threatens walk out the door. That's the thread worth pulling because Ivan Turkovich's piece isn't really about AI. It's about a 60-year pattern of people with budgets looking at people with keyboards and asking, do we really need them? COBOL was supposed to be the answer in 1959. Grace Hopper and the Coda Soul Committee built a language so close to English that business managers could read it, understand it, eventually write it themselves. The priesthood of technical experts would be disbanded. What actually happened is one of computing's great ironies. COBOL succeeded beyond anyone's expectation and created an entirely new profession of COBOL programmers. Today, those programmers are in desperate demand because the systems they built process trillions of dollars and nobody else learned the language. A tool designed to eliminate specialists became the longest-running job program in tech history. Then expert systems in the 70s. 4th-generation languages in the 80s. Visual Basic and Power Builder in the 90s. One commenter remembers Power Builder as the flavor of the month that was going to make everything drag and drop. UML and model-driven architecture in the 2000s. Low-code platforms in the 2010s. Every single generation believed they were witnessing something unprecedented. Every single generation was replaying the same scene. Here's what the bootstrapism lens reveals. Each wave did democratize something real. COBOL made business logic expressible. Spreadsheets put computation in the hands of accountants. WordPress let anyone publish. React Native let small teams ship to both platforms. The tools worked. They genuinely put power in more hands. But they never eliminated the need for the person who understands what happens when the abstraction leaks. When the database locks, when the race condition bites, when the elegant drag-and-drop workflow hits a requirement that doesn't fit the grid. One commenter breaks the optimist ranks, says LLMs now sit in meetings, take notes, maintain context, and the window keeps expanding. Fair enough. But Turkovic's history suggests the right question isn't whether this wave is more capable than the last. Every wave was more capable than the last. The question is whether capability at the interface layer changes what happens underneath. And 60 years of evidence says the underneath always reasserts itself. The article is open. The history is there for anyone to read. That matters more than any prediction about what comes next. So what happens when capability meets classified infrastructure? OpenAI just signed on to deploy models inside the Department of Defense's classified network. The Department of War. They're calling it the Department of War now, and Sam Altman just signed a deal to put OpenAI's models inside their classified network. Read that sentence again, slowly. The company that started as a nonprofit to ensure artificial intelligence benefits all of humanity just agreed to deploy its most powerful models behind classification walls, where the public cannot see what they're used for. And the announcement frames this as a safety achievement. The language is remarkable. Every sentence is load-bearing. Deep respect for safety. Human responsibility for the use of force. Technical safeguards to ensure our models behave as they should. These are not reassurances. These are terms of surrender dressed in the vocabulary of principle. When you have to specify that humans remain responsible for the use of force, you are acknowledging that the alternative is on the table. You don't write that clause unless someone asked about removing it. The question nobody in that press release wants you to ask is this: what does a classified deployment mean for safety research? OpenAI's entire safety argument rests on transparency, on red teaming, on external evaluation. Classification is the architectural opposite of all three. You cannot have independent safety audits of systems you cannot acknowledge exist. You cannot publish research about failure modes discovered inside a classified network. The safety principles they cite become unfalsifiable the moment the deployment goes dark. And then there's the ask at the end. OpenAI wants the Department of War to offer these same terms to all AI companies. On its face, that sounds magnanimous. Run it forward. If every AI company must accept prohibitions on mass surveillance and autonomous weapons to get a defense contract, OpenAI has just written the procurement spec in its own image. First mover sets the standard. The company that signs first defines what reasonable means. The employees who signed the "We Will Not Be Divided" letter now face a binary. Several commenters are voting with their wallets, canceling subscriptions. But individual consumer choices don't redirect defense contracts. The structural question is whether Anthropic, which reportedly had the same red lines and walked away, made a different calculation or simply hadn't been offered the right price yet. The world is a complicated, messy, and sometimes dangerous place, Altman writes. That's the sentence you reach for when the simple version of what you did sounds worse. Moving on! I spent 3 years building authentication systems for a platform that served in both children and adults. The single hardest engineering problem wasn't the cryptography or the session management. It was the moment a 13-year-old typed 19 into a date of birth field and clicked submit. Every system we built after that was theater performed for regulators who would never use the product. California Assembly Bill DTF is that. Theater, codified. Starting January 2027, every operating system sold or distributed in the state must collect age information during account setup and expose it to app developers through an API. The law breaks users into 4 brackets. Under 13, 13 to 15, 16 to 17, and 18 plus. Windows already does this with Microsoft account creation. Apple already does this. The bill is, for those 2 companies, a rubber stamp on existing practice. The first principles question is what this law actually requires versus what people think it requires. Read the text carefully, and it's not demanding biometric scans or government ID. It's asking for a toggle, a self-reported age bracket, passed as a signal to developers who request it. One commenter on Hacker News skimmed the actual statute and found the liability safe harbor buried at the bottom. Operating system providers aren't liable for users who lie about their age. The enforcement mechanism is, to put it gently, aspirational. Now run this forward to Linux. The bill says operating system providers. Canonical distributes Ubuntu. Red Hat distributes Fedora. Do they add a date of birth prompt to their installers for California IP addresses? Does Linus Torvalds comply on behalf of the kernel? The Linux Mint subreddit's reaction is predictable and correct. Anyone who doesn't want the prompt compiles without it. The law assumes a world where operating systems ship from identifiable companies to passive consumers. That world is shrinking. The unintended consequence is the API itself. Once you build a standardized real-time endpoint that broadcasts whether a user is a minor, you've created a new data surface. Every app developer gets a binary signal about every user's age bracket. The law frames this as child protection. Engineers who've built these systems recognize it as a new vector. You wanted to protect 14-year-olds. And you build a system that tells every installed application exactly which users are 14 years old. The comedy writes itself, except it's architecture. And architecture has consequences. Architecture has consequences, and nobody architects consequences quite like OpenAI, pause, who just raised $110 billion to prove it. 2 gigawatts. OpenAI has committed to consuming 2 gigawatts of AWS Trainium compute as part of this deal. For context, that's roughly the output of 2 nuclear power plants running at full capacity dedicated to inference. Bury that number in a press release between the headline figures, and most people skip right past it. But that number tells you more about where AI is heading than the valuation ever could. The dollar figures are staggering on their own. $110 billion, $730 billion pre-money valuation. Amazon puts in $50 billion, Nvidia $30, SoftBank $30. But follow the money, and you notice something familiar. Amazon's investment is tied to OpenAI running on AWS. Nvidia's investment is tied to OpenAI buying Vera Rubin Systems. This is the Cloud Wars playbook from 2014, when Amazon offered startups AWS credits to get them locked into the ecosystem, except the credits now have 9 zeros after them. In 1995, Netscape went public at a $2.9 billion valuation with essentially zero revenue, and it worked. Briefly, because they were the interface layer between users and the internet. One commenter asks the obvious question, how is OpenAI not Netscape 2026? First mover advantage, no network effect, no moat, racing to stay ahead of companies with functionally unlimited resources. The parallel is instructive precisely because of how Netscape ended. Microsoft didn't out-innovate the browser. They out-distributed it. They owned the operating system. Amazon owns the cloud. NVIDIA owns the silicon. OpenAI just took $110 billion from the two companies best positioned to commoditize everything OpenAI builds. The press release calls this a partnership. The balance sheet calls it a supply chain dependency. What genuinely impresses me is the engineering ambition buried in the announcement. A stateful runtime environment on Bedrock is a real architectural innovation. Persistent model state across sessions would change what's possible for agent systems. That's elegant work, and it deserves recognition regardless of who captures the value. But the architecture of the deal itself is worth studying. 3 gigawatts of dedicated NVIDIA inference capacity, 2 gigawatts of AWS training, custom models built specifically for Amazon consumer products. OpenAI is building the most sophisticated AI infrastructure on the planet, and every kilowatt of it runs on someone else's hardware, optimized for someone else's chips, serving someone else's customers. The question isn't whether the technology works. The question is whether OpenAI is the product or the customer. Moolah! Run this forward 5 years. Actually, don't. Run it forward 5 days, because nobody involved in Operation Epic Fury appears to have thought much further than that. Imagine you're an engineer tasked with eliminating a nuclear program. You know where the enrichment facilities are, you know the centrifuge counts, the buried sites, the redundant systems. Iran spent 2 decades hardening against exactly this scenario. You could design a precise contained operation. Instead, you're hitting the Supreme Leader's compound in a residential district on a Saturday morning while millions of people are walking to work. That's not counterproliferation. That's a statement, and the statement has nothing to do with centrifuges. The timing alone tells the story. Hours earlier, Oman's foreign minister said negotiations had made significant progress. Hours. The diplomatic track wasn't failing. It was working. And someone decided that was the problem. One commenter cuts to the core of it. The take-home message is that the only way for any country to be secure is to have nuclear weapons. That's not cynicism. That's the rational game. Theoretic conclusion every state actor on Earth is drawing right now. Libya gave up its program and got regime change. Ukraine gave up its arsenal and got invaded. Iran was negotiating and got Operation Epic Fury at dawn. The incentive structure is screaming a single message, and it is the opposite of non-proliferation. The call to the Iranian people is worth examining with engineering precision. Take over your government, Trump says, while cruise missiles flatten military infrastructure and blasts echo across Tehran. The theory of change appears to be destroy a nation's defenses, then invite its civilians to do the difficult political work of building something new from the rubble. This has been tested before. The results are documented extensively. They are not ambiguous. Meanwhile, Iran's retaliation is hitting U.S. bases across the Gulf, Qatar, Bahrain, the UAE. Every one of those hosts critical American military infrastructure and also happens to be a major node in global energy and logistics networks. What began as counter-proliferation rhetoric is, within hours, a regional war with no articulated exit condition. That's the engineering failure worth naming, not whether the missiles hit their targets, whether anyone designed what comes after. This has been your daily tech feed for Hacker News for February 28, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Qwen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that makes tomorrow worth showing up for. We'll see you back here tomorrow.